We are in Chapter 5, Section 3. We get to learn a new form today. We do love our slope y-intercept form. We love it. However, there are times when we could use another type of linear form that is super useful. And the form is called point-slope form. Okay, and point-slope form is absolutely familiar because it's something that you have actually already learned, but it's just transforming an equation you know. And the equation that you know is the slope formula. So everybody say with me the slope formula. M equals
y2 minus y1 over x2 minus x1.
Okay, so this is the point slope, but it looks different. Okay, it's going to look a little different, but this is the same equation that point slope form is, except for one thing. Imagine that we only know one point. So when you see this slope formula, because you see those little sub numbers there, we see a point called x1, y1. That's point 1, right? And we see a point x2, y2. Okay? So we are actually saying we know 2 points. We can name them. We can substitute numbers in there. In our point slope form, we only know 1 point. So imagine that we only knew 1 point, so we'll name it point 1. Okay? So instead of writing y2 minus y1, x2 minus x1, if I only know 1 point, I could write it like this. Right? Some unknown y minus y1 over the unknown x minus x1. So the only thing different here is, do you see, I can't name 1 point. 1 is unknown. All right? And then the other thing that looks a little different is we move things around a little bit with point slope form. And so how could we move things around? If I wanted to get rid of this denominator here, what could I do? That's right, multiply by it. So I could multiply both sides by that denominator. And that would isolate the y's all on one side. Do you see that? And once we do that, we have point slope form. And so here's what it looks like when we put y on the left side. Y minus y1 equals m times x minus x1. It is just your slope formula that has been transformed a tiny bit. So we're going to see that if you know a point and you know the slope, yes, you could distribute it. You could distribute the slope across these, and you're going to be able to transform this equation into y equals mx plus b again, if that's what you want, if that's the type of equation you want to write. Okay? But we sometimes are asked to just write an equation in point slope form. Leave it in this form. Okay? So let's see how we do that. We would just substitute a known point and slope into this form. All right, so here's the type of question you might see. Write an equation in point-slope form of the line that passes through negative 3, 1 and has a slope of 3. You need to have that whole sentence down because sometimes in a test you will see something like that and you have to know now how to put this equation into that form. So as we have done before, whenever we are going to put an equation into a form, it says right in the question, put it into this form. We're going to start with a model of that form and we're going to keep writing it over and over again so we have it down forever. Okay? So we say y minus y1 equals m times x minus x1. Say it when you write it. Everyone, please say it with me. Ready? Y minus y1 equals m times x minus x1. Just keep saying it all day long. And now, just substitute. Be careful when you substitute the point and the slope in. Because the y's are on the left. Sometimes people accidentally put the x's in where the y is. We're putting the point in for the named point. The one that is x1, y1. Right? That's the named point. So who can substitute this stuff for us and read it? Chris.
So y minus 1 equals 3 cut
Minus negative 3. Okay, so we could actually change that where it says x minus negative 3, we could just say x plus 3. Right? And there you have your answer, you're done. If the question says write an equation in point slope form, is this in point slope form?
Yes.
Yes, and you're done. You don't have to go further at all. But will we sometimes have to go further? Yes. Okay, but we don't have to here. We're done. Okay, let's try this again with another one. All right, here. Write the equation for this given point and slope, and write the equation in point slope form. Very good. So we simply substitute the point and the slope into point slope form. Okay, how about graphing an equation that's given to us in point slope form? So we do not have to transform the equation into slope-intercept form. We can simply pull out what we need. And to graph a line, we simply need slope and a point. That's all we need. So who can, let's all say the slope here together. M equals what? 1/2, right? Look at, the slope is 1/2. Okay, I see what you're saying. And now we need a point. And so can you jot down the point that is visible in this equation? Be super careful because the negatives can mess you up, right? Remember the model you could write above here is y minus y1 equals m times x minus x1. Be careful of the subtraction, right? Okay, Wesley, what's the x value? Good job. It's -2 because I see a +2 here. It must be minus -2, right? That's your x value. And your y value, what is that?
2.
Good job. It's a +2. Because as we see in the model, we're subtracting the y value. Subtracting the y value must be +2. So the tricky part is pulling the point out. The slope is very easy to see. Now when you have a point and slope, what can you graph first? What must you graph first? The point. It's got to be the starting spot for us, right? So let's walk -2 and fly 2. We have a point. That's the known point. And now how will we find a second point? How do we find a second point? Use your slope. And don't forget to start from the known point. Right. Some people mistakenly start from 0, 0 for some reason. But 0, 0 may not be on this line, right? So we can't start there. We have to start from the known point. So from our known point, we're going to rise 1 and run 2. There you go. We now have 2 points. We could also rise -1 and run -2, right? And you do draw a line. Yes? Use a ruler on your paper, please.
Wouldn't y be negative since it's minus y minus 2?
No. Look at it. It says y minus y1. y1 is +2 because you're subtracting it. Look over here. When you substituted y as 1 in here, you wrote y minus 1. And y was positive. See that? And so over here, again, we're subtracting something. Subtracting 2, 2 is positive, so 2 is positive in our point. So you might want to write the model above it and make sure that you see that this entire 2 is your y that has been substituted, see? Okay? Questions? Any other questions so far? Okay, again, here, let's start by identifying the point and slope so that we can graph this. So both of them can be tricky, right? So once again, you might want to write the model above this. And let's say the model together. Y minus minus x1. Okay. So the slope is looking a little tricky here. You see that? What's the invisible number that is, very good, to the right of this negative sign is a 1, so the slope is -1. And our point, starting over here, x minus the x1, so what is our x1? 2. And y1 is 1. Positive, they're both positive. Thumbs up if you understand why they're both positive. Do you see? Because this model has subtraction in it. Okay? And now we need to graph. And to graph, where do we start, Abby?
Wait, how'd you get nervous?
All right, so we plotted our point, and we used our slope to find some other points, and we drew the line. Okay? So you don't need to transform the equation to do this. You simply need your slope and your y-intercept. Okay? And you may do that yourself.